first equation that we're going to start off with is 5x plus 2 equals 2x plus 14. Now, we've said when we first started solving equations this year that your goal is always to get the variable by itself. Well, that kind of is a difficult goal when you have a variable on both sides of the equation. Since most people do not like the variable on the right-hand side of the equation, they prefer it on the left-hand side, we're going to solve all these the same way, and our first step is going to be to move or get rid of, however you want to call it, the variable, the term with the variable that is on the right. So again, that is going to be my first step. Move term with variable that is on the right. Move term with variable that is on the right. So the term that is on the right that has the variable is the 2x. The opposite of 2x is negative 2x. As always, you have to do it on the other side of your equation. Now, the only thing that we can subtract that from is a like term. It has to also have an x, so it has to be from the 5x that I'm getting rid of it from. So that's going to leave me with 3x plus 2 equals 14. After you've done that step, then it should be a breeze. Now it's just a two-step equation. Nothing's different about it now. You just solve it like normal. Solve like normal. So, first step, second step, and I'm sure that most of us are to the point on these last two steps where we probably really don't have to show what I have written here in blue for these last two steps, because again, most of you are fine and comfortable with this mentally, the last two steps. Okay? I do want you to, since this is our first time with the first step in this year anyway, I do want you to show me the first step, okay? But again, the other two steps, that's going to be your choice whether you're showing it or not. Owen, let's use those for writing instead of drumming. All right. So let's do another one that's a little bit more challenging because there's going to be some negatives. That doesn't mean other people should start tapping. So you can see in this equation we have m's on both sides of our equal sign. And we're going to get rid of the term with the m on the right. Do you want to try doing it? All right, you try. I'll pause. So let's see how you did. So hopefully the first thing you did was saw that there was a minus sign or a negative sign, same difference, out in front of the 9. So we need to do the opposite. So plus 9m on each side, which is going to get added on to my 2m because those are like terms. So that's going to give me 11m plus 4 equals negative 18. Now I'm going to go ahead and show the steps since I'm doing the notes up here and I don't want to just show all mental math. Minus 4 on each side. That's going to leave me with 11m equals negative 22. And then lastly, dividing by 11 gives me final answer of m equals negative 2. Raise your hand if you got that right. All right, let's bump it up a notch and get a little harder. So the next ones that I'm going to show you are going to include the distributive property. So before we move anything, we have to distribute. Distributing is going to be our first step, okay? Yes, this is our next example. First step is going to be to distribute. Then you're going to move variable term. And then solve like normal. So you will know that it is a distributive property problem when you see parentheses there and a number right outside the parentheses. That's going to be your clue. Ooh, I need to distribute first. Do not move anything until you distribute. And sometimes you might only have to distribute on the right. Sometimes it's only on the left. This one is both, obviously. So I'm going to go ahead and distribute my 2. 2 times 5x is 10x. 2 times -1 is -2. Then on my right-hand side, 3 times x is 3x. 3 times 11 is 33. Now I have an equation that looks like the ones that we just went through solving that you all did so well on. So the next thing that I want to do is the term that has the variable that's on the right, the 3x, I want to move it. So I'm going to subtract 3x from both sides to get rid of it. That gives me 7x. And now it should be a breeze once you get down to these 2 steps. So we're adding 2. And again, I don't need to really see these last 2 steps. And then dividing by 7. So x equals 5. All right, so I'm going to give you a problem similar to this one for you to try on your own, okay? Are you ready, or are you still writing? Ready. Okay. Any questions from over there? You had a question earlier for me. You good now, Antonia? Okay. All right, here comes your next example. I would like for you to try this one on your own. On your own, all the way. Get one answer, one solution. Those are both y's. I just wrote them a little bit different. So, first off, let's start by distributing. So we need to distribute on both sides. 4 times 2y is 8y. 4 times 1 is 4. On the right, 2 times y is 2y. 2 times -13 is -26. Next step, get rid of that 2y. That's on the right, so I'm going to subtract 2y. That's going to leave me with 6y plus 4 equals -26. And again, at this point, if you want to start doing it in your head and just show me 6y equals -30, so y equals -5, that is fine. You don't have to show me the other steps. But I do think that especially when you have negatives, that it might be helpful for you to show your work. But that's your choice. So if you made a mistake, find your error and then ask me questions. That we've worked with so far have had one solution. All equations above have one solution. We're getting ready to see some equations that have either no solution or infinite solutions. Okay? So there's really 3 options. One solution, no solution, or all solutions, infinite solutions. Yes, I'm glad it was introduced to you in pre-algebra. That's great. So let's talk about if it has no solution. For instance, if we have the formula or the equation, 9m minus 4 equals negative 3m plus 5 plus 12m. Okay, so in this equation, I don't have any parentheses, so I don't have to worry about distributing, but I have two terms over there with an m on the right. So thank you. Before you move it, combine it. Okay? So we're going to combine negative 3m and, sorry, I want a different color, negative 3m and 12m to get 9m, right? So now that we've done that, we kind of see what the issue is. There's a 9m on both sides, but on one side it's minus 4, and on the other side it's plus 5. There is no number in the world, even those imaginary numbers, there's no number in the world that you could put in for m to make this work. Because if we do our next step, which is to move the variable on the right that has the exponent, or the variable, if we do that, then we end up with nothing here except for minus 4, and nothing over here except for 5, and negative 4 does not equal 5. Okay? So this would be no solution. So when it's no solution, you can see that the term with the variable is exactly the same, 9m and 9m, but the constant is different. So variable term same, but your constant is different. So again, variable term is the 9m. Those are the same, but your constant, the minus 4 and the plus 5, those are different. Okay? That's how you know that it's going to be no solution. Now I'm going to give you one that's going to be all solutions, or infinite possibilities. Okay? And I'm telling you which ones they are, but then I'm going to mix them up and you're going to have to tell me which is which. Matthew? All right, let's look at this problem. Okay. So right now it looks like the type of problems that we did at the very beginning of the notes. There's no way to know there's anything different about it. I see parentheses, so that's a clue that I'm going to need to distribute. So I'm going to go ahead and distribute first, like normal. And once I distribute, I notice that they are exactly the same. Everything about it is the same. So that's when it is infinite solutions, or all solutions. It means the same thing. Exactly the same on both sides. So again, if your variable, if the term with your variable is the same, maybe I should do it there, and your term with the constant is the same, then it's all solutions. However, like on the last example, when the term with the variable is the same but the constants are different, it's no solution. Okay? So that's going to be your clue. So I'm going to put an equation up here, and I'm not going to tell you which one it is And I want you all to figure out, is this a no solution or is this an infinite solution? Don't say anything, don't shout anything out. If you want to sit there with your hand raised, that's fine. Okay. Now hopefully you see that that is distributing. We haven't practiced one of these distributing today. We've done them, but not today. What are you really distributing over there? But it's a negative sign, but you can think of it as being a negative 1. Okay. We're not saying anything out loud. We are only talking about the distributing part of this. All right, let's see how you did on this one. So, parentheses, I need to distribute before anything else. We said this is like a negative 1. So negative 1 times 3 is negative 3. Negative 1 times a negative 2x would make this a positive 2x. Now over here on the other side, nothing changed about this other side. And what I notice, and maybe you don't notice it yet, sometimes you don't catch it, but I know that we're kind of watching out for it, that my variable terms are the same, but my constants are different. So the answer to this is no solution. And the reason is because 7 does not equal negative 3. 7 does not equal negative 3 no matter what you put in there for x. Okay? So tomorrow you're going to have on your assignment, you're going to have problems that have one solution, like we did in the very beginning of our notes. And then you're going to have problems that are either going to be no solution or all solutions, and you'll have to determine which it is. After you distribute, after you combine like terms, then you'll be able to tell. Okay? All right.